Greetings to every one of you. So in this video we are going to discuss a very important concept in scheduling policy, that is first come first serve, convoy effect. The convoy effect, it is a disadvantage occurred in first come first serve scheduling algorithm. For example, if a first arrived process takes long time, which leads to the wastage of CPU time, ultimately it reduces the efficiency of the system. Let me explain the convoy effect with the help of two scenarios. So in the first one we have three processes, and this process 2 enters first, whose burst time is large, that is 60 milliseconds. But whereas in scenario 2, the process 2 will be executed at last. Now we'll find out the completion time and turnaround time for both the tables. After that we'll continue our discussion. So the very first process that is enters, it is P2. At time 0, P2 that is enters, and its burst time is 60. So 0 to 60. So during that time period, we have got two processes that is entered. One that is P1 at 1, and another one is P3 at time 2. So now P1 taken for process, its burst time is 2 milliseconds. So at 62 millisecond, the P1 is get over. Then the P3 enters at time that is 2. Its burst time is 3. So 62 plus 3, that is at time 65th millisecond, the process P3 is over. Okay. So now their completion time, that is for process 3, it is 65. You can go through from right to left. So completion time of process 1, it is 62. Similarly, completion time of process 2, it is 60. So the turnaround time can be calculated as completion time minus arrival time. It is 62 minus 1, it is 61. This is 60 minus 0, it is 60 only. This is 65 minus 2, it is 63. Now we have to calculate the waiting time. So waiting time can be calculated as turnaround time minus the burst time. So it is 61 minus 2, it is 59. It is 60 minus 60, it is 0. It is 63 minus 3, it is 60. So if we get the total, it is 119 divided by 3. Approximately it is 39 points, that is 6. Okay. Then the second scenario, process 1 enters first at time 0. Process 1 enters, its burst time is 2 milliseconds, and process 3 enters second at time 1. Process 3 enters. So process 3 is burst time is 3 milliseconds. So 2 plus 3, that is 5. At time 5 millisecond, process 3 is over. Now finally we are providing the processor to the process 2, okay, which takes 60 milliseconds at 65, that is 5 plus 60, 65, 65th millisecond, the process 2 is over. Now calculate the completion time. The completion time of process 2 is 65. Completion time of process 3, it is 5. completion time of process 1, it is 2. So calculate the turnaround time, that is turnaround time is completion time minus arrival time. So 2 minus 0, it is 2. It is 65 minus 2, it is 63. And this is 5 minus 4, it is 5 minus 1, it is 4. So now calculate the waiting time. So waiting time is turnaround time minus burst time. So take the turnaround time, it is 2 minus 2, it is 0. It is 63 minus 60, it is 3. It is 4 minus 3, it is 1. So the total value, it is 4. The average waiting time is equal to 4 by 3. It is nothing but 1.3 milliseconds. So just to compare these two scenarios. So in the scenario 1, the waiting time is approximately, there is 39.6 milliseconds. But whereas here it is there is 1.3 milliseconds. It is drastically reduced. How? Because of executing the big process at last. So actually this is the disadvantage. So suppose if you have the scenario, the case 1 like this, so what will happen? The small processes will be kept on waiting for the completion of the large one. Okay, why it is called convoy effect? Like the chief minister's convoy is going, so all other the vehicles will be stopped. Okay, all the small vehicles will be kept stopped. That is the effect. So once if the large process is taken for account, the small processes will be kept waiting for a long time. Similarly, there is another concept which is connected with this convoy effect, is what is called the starvation. Starvation, it is not existed in first come first serve, but in priority scheduling, where we are using the priority scheduling, there we may get this kind of problem, is what is called starvation. So any process that is kept under wait state for an indefinite period of time, then it is what is called starvation. Okay, so that is another concept. It is related with this convoy effect. I explained what is convoy effect, and with the help of the two scenarios, how this waiting time is differ in both the scenarios. And also I gave a note about this starvation. I hope you understood. Thank you for watching. Bye.